Edexcel Core Pure, Calculus 5, Integration Techniques. Substituting x equals tan u. So just to recap some of the things we've seen previously. We know that the result of the standard integral of 1 over 1 plus x squared dx is arc tan x plus c. We can write sec squared u as 1 plus tan squared u, and the derivative of tan u with respect to u is sec squared u. The reason we have x and u both mentioned here is that we're going to be exploiting the fact that if arc tan x is written as u, then x can be written as tan u. The substitution x equals tan u may be useful when you are dealing with integrations involving 1 plus x squared. So this is one of the features we're going to be looking at in the next few slides. So this is the definite integration we are going to be working with, and the fact that we have a 1 plus x squared is the suggestion to let x equal tan u. So that gives us dx by du is sec squared u, and dx is going to behave like sec squared u times du. Don't forget it's a definite integral, so we need to change the limits. So when x equals 0, find u, and when x equals 1, we need to find u. So when x equals 0, tan u is nothing and u is nothing, and when x equals 1, tan u equals 1 and u equals pi by 4. Some people like to put x equals on the original limits as a reminder that the new limits are going to be u equals pi by 4 and u equals 0. So this will now become 1 over 1 plus tan squared u to the 3 over 2 times, and dx is going to be sec squared u du. So now we can try to simplify this down now. So it's the integral from 0 to pi by 4 of sec squared u, and we know that 1 plus tan squared u is sec squared u, but it's still to the power of 3 over 2. So just looking at that denominator, we've got sec squared u to the power of half, which is sec u, and then it's cubed. So that's sec squared u du. Sec squared over sec cubed is 1 over sec, and 1 over sec can be written as cos u. So we've already made a lot of progress towards completing this integral. So we've shown that this integral can be written as the integral of cos u du with these new limits, u equals 0 and u equals pi by 4. If we integrate cos u with respect to u, we get sine u, and then we can sub the top limit in. So we're going to get sine pi by 4 minus sine of the bottom limit. So the answer is 1 over root 2. Sine of nothing, of course, is nothing. And there we have completed the integration. So some of the key steps here are to recognize the 1 plus x squared, which prompts the x equals tan u substitution. Don't forget you need to create new limits. And when we make the substitution, the whole point of making the substitution is that difficult denominator can simplify right down to sec u cubed. Once we get it down to 1 over sec, it makes sense to write it as cos u, and then we can integrate cos u between 0 and pi by 4. So in this integral, the numerator is clearly a little bit more complicated, but we can still see this x squared plus 1 in the denominator. So I'm going to try x equals tan u. So this is one method that could be used to complete this integral. dx by du is sec squared u, and dx is sec squared u du. Okay, so there's a lot to think about here, so we're going to take it nice and steady. So the numerator is going to become 3 tan u plus 2, and the denominator is going to become tan squared u plus 1. dx is sec squared u du. Sec squared u du is going to be significant in a moment when we rewrite this as 3 tan u plus 2 over 1 plus tan squared is of course sec squared. So what looks as though it's a very complicated integral is starting to simplify a little bit. So we've now got the integral of 3 tan u plus 2. Now this is an integral that we can quote the result to. If you integrate tan u, you get ln of the modulus of sec u. Integrate 2 is obviously 2u. Now the problem we've got is we need now to be able to substitute back for x. So now I'm going to use the fact that sec u is the square root of 1 plus tan squared u, and then I can reintroduce x where it says tan u. So now this becomes 3 ln sec u is the square root of 1 plus tan squared u, which is 1 plus x squared to the half, and u is arc tan x. From the original substitution we had x is tan u, so u must be arc tan x plus c. And just to tidy this up a bit, I'm going to use my power law to bring this index of a half to the front. So 3 over 2 ln 1 plus x squared plus 2 arc tan x plus c. Again, just picking out some of the key steps, looking for the x squared plus 1 in the denominator suggests that x equals tan u may be worth pursuing. That allows us to make a complete substitution based on dx and x, and the denominator simplifies to the point where it will cancel with the sec squared u, and then we need to very carefully, once we've integrated, we need to write sec u in terms of x again. So in summary, integrals involving 1 plus x squared may be transformed using the substitution x equals tan u. The resulting integral may need a further technique, so don't be surprised if you have to do a further method or use an trig identity in order to simplify the integral further. And if it is a definite integral that you've been given, don't forget that the limit must be changed to the equivalent of the new variable, in this case u. In the next session we're going to be looking at substituting x equals a sine u or x equals a tan u.